Hi, Aviad. Good to have you here on the Dancast. As an introduction, I'm not going to even introduce you. I want you to introduce yourself. Who are you?
All right. It's an honor to be here. My name is Aviad Cahana. I'm the CEO and founder of Avelo Labs.
Cool. Avelo Labs, that is a sort of new company on the horizon. We've heard a lot about Avelo. Not everyone knows what Avelo actually is. So how did you decide to reinvent scuba?
Well, it's not so much that I decided to reinvent scuba. I asked myself the same question that any diver asks, and this is, why does this have to be so heavy? Does it have to be so heavy? If it does, we'll suffer through it, but does it? The surprise part was that it doesn't. So it's not so much that it's an intuitive question, and like everything else in life, you ask yourself that when you introduce to scuba for the first time, and then you kind of live with it because that's what is. But that was the question. If you go back, I'm a scuba instructor who worked in the Red Sea primarily and then around the world, and then got out of scuba and developed a career in chemical and environmental engineering. And I was out of the scuba world for about 10 years. So I asked that question after coming back into it. And the question was posed in my own head is, why is it still so heavy? I mean, we advanced since my early days in scuba, yet it's the same. That was the impetus.
All right. So weight is one thing that you try to tackle with your system. The other one is buoyancy, which is really completely different with your system than it is in traditional scuba. Can you explain what exactly is different?
So let's start from what Avelo is. And when you think about what scuba is, you're really, if you're a diver, you want to take a certain amount of air to spend time underwater. We're talking about open circuit, or primarily open circuit. And that amount of air it only weighs 6 pounds. If you take a tank and you compress the air into it, you want to take 6 pounds. That's it. And you don't want to think about things like buoyancy. Yes, you can practice it and it becomes second nature. We're all instructors. I came into it as an instructor, and my buoyancy was perfect.
As
buoyancy,
is every instructor's.
Yeah, and I would say, you and I started to talk about it before. We know that people believe that they have good buoyancy. There's something to be said about having good buoyancy after 20 dives in a calm conditions. Good buoyancy doesn't equal good buoyancy skills necessarily. That is something that you need to gain if you dove in various conditions. I would say, if you ask yourself, I'll pose that question to you. If you say, okay, this person has their buoyancy dialed, how many dives do you think that means, and in what environments? To really overall, wherever you're going to throw them in the world, their buoyancy will be good.
That is the question to me. Well, it's a loaded question.
Mm-hmm.
But if someone had a good instructor and was put onto thinking about buoyancy right from the beginning, and yes, I say thinking about it because it's a lot of thinking involved, anything between 20 and 250 dives.
So my answer is a little different. I'm saying it's probably between 300 and 500 dives in various conditions, and really, to me, the only people that I've seen that actually hone buoyancy for real either worked as a dive master, for at least 6 months. Your buoyancy is never good until you have 6 divers behind you, and you need to add weight. This person forgot the weight. You didn't know how to weigh them. If anybody that worked as a dive master will understand what I'm saying, you have to have a group that you're responsible for, and then your buoyancy gets excellent because you're playing with giving and taking weights all the time, that then you truly learn lung control, especially if you've done it in different environments, like clear water, clear warm water, freshwater, dark, night dives. It's those various experiences that really put somebody that they can close their eyes underwater and they can stay on a nail if they needed to. So, and that takes time, and it takes a lot of practice. Yet, you have a lot of recreational divers that believe that they have that. But Avelo wasn't invented for this. And it took a while to even understand that it will make that much of a difference. Avelo came from the concept that you need to carry 6 pounds. In today's world, you take 6 pounds of air, roughly. It's 5.56 for those of us that are going to latch on to the numbers. 6 pounds. We can in metric. Should we do this in metric?
Okay,
Yeah?
let's go metric.
Yeah, metric is much easier to do. You have an 11.1 liter tank that is filled with 200 bar. That gives you 2,220. You multiply that by 0.00129, which is the kilograms per liter. And that's the density, and you're going to get 2.73 kilograms of air.
And now back to imperial for the rest of our...
I knew that you were going to do that. You multiply that by 2.204.
Right.
So you get whatever. You get, just shy of 6 pounds. But you think about what we're doing today. You take 6 pounds, you put it in a pressure vessel that we like to call the cylinder or the tank. And that thing is heavy. It's heavy because it's a boiler. It's, the rules of and regulations go back to like the 1800s on those things. But that's what scuba was. So you take 6 pounds, you put it in something that weighs 32, 33 pounds, and you should know if your instructor was good, you should know that you're going to consume that gas underwater. So what do? You have to add weight. Otherwise, you're going to float at the end of the dive. And if your instructor was really good, he actually taught you that in that regard, there's no difference between aluminum and steel. There's this conception that a steel tank, you don't need weights. No, you just already took the weight in the tank. It's just a denser material. So it doesn't matter what pressure vessel you're taking 6 pounds, putting it in a pressure vessel, add weight, and now you have no choice but to start the dive negative. Okay, so that's good for very good swimmers, which that's how scuba started. But very good swimmers, there's not a lot of them. Like we're talking Phelps. There's not a lot of them. So now you need to add some sort of a flotation. Because of that dynamics, that taking mass of air, weights, and putting all of this in the tank, you have to start the dive negatively buoyant. Well, balloons. Balloons are great flotation devices. We glorify them to call them BCD. And then you have an entire scuba world that will argue whether the vest versus the backplate and wing balloons. It's a balloon.
Okay.
You put a balloon, it floats you, and then you start the dive by dumping it, developing a significant negative force, and then you inflate it to where you need to be, and that's the simplicity of scuba. Except those BCDs themselves, even empty, have their own buoyancy. They're buoyant. They're displacing some water. So guess what you need to add?
Weight.
More weight. And then you put an exposure suit that has its own buoyancy. And those are lessons. There were lessons that were learned through the development of Avelo of exactly how much buoyancy a wetsuit is. But at the end of the day, every element that you add more weight, you end up with significant amount of weight. And again, everybody got used to it. So the instructor will go to a student on day one and they'll ask, why is this so heavy? And very nicely you tell them to shut up. Very, very, you're like, yeah, because it is. Or you take it the macho way and go, well, if you can't carry it, you shouldn't be diving. Avelo was born from rethinking. It was born from, okay, I understand that we're going to lose buoyancy and all those things are buoyant, but there are very lightweight things. They exist. Carbon fibers used, firefighters, special units, paintball. And while you don't want to dive with devices that were not made for underwater, that is not to say that lightweight cannot exist in scuba. So this is not an endorsement to take an SCBA tank and go dive with it by any means, but they do exist. And people ask, why can't I take a lightweight shell? When you go to the concept of it, let's go back to 6 pounds, right? 2.73 kilograms. That's
Right.
what you really want to carry. If you could put us in the lightest shell possible, and only when you go into the water, you start to compensate for that gas loss by simply taking the most abundant thing around you, which is water, and just pump it into the tank. In essence, Avelo was born to say, you have a certain pressure vessel. If you could just dive with your 6 pounds of air inside and just make it smaller as you dive. Every time you breathe 1 gram of water, just put 1 milliliter of water to compensate. You will have fantastic neutral buoyancy the whole dive, like clockworks, and the weight can be reduced substantially. But the buoyancy wasn't the driving force. It was weight. It was to reduce weight. The buoyancy was discovered after the fact. In fact, the idea was born through a dive. There was a dive in Maui that you kind of waddle for a while until you get to. It's one of those dives that you ask yourself, does it have to be this heavy, really? So it was born through the dive, the idea that, wait, if you have a lightweight shell, you can just pump water into it. 10 minutes into the dive, I go, accumulators. There is a device that can do that. I know of devices that can do that. I just need to find a way to pump water into it. And then, of course, the pressure is going to go up, the other considerations. But by the end of the dive, the idea was sort of formulated. Turns out that inventing things takes very little time. Developing things is very different. So
how long did it take you to develop the system as it is today?
It's ever changing. So as it is today is from that moment to now, which is about 7 years. But to get to a prototype, so the original idea was not what you're seeing now. It went through stages. You know how I just said the idea was every gram that you breathe, something needs to pump in. The original concept was a regulator. You know that a regulator is just an energy wasting device, right? All you're doing is you open a demand valve, the high density air goes in, your lung takes as much as they need. That's why it's called a demand valve. All you're doing is you're opening a valve. But as any good dive shop owner knows, filling that tank takes a lot of energy, and we waste it. So a regulator can be made to be a pneumatic pump. Simple clockworks. You use the energy that you breathe, or while you breathe, you can use the same energy to actually pump water into the tank. And even in the dive, with a little bit of understanding of thermodynamics, you can kind of roughly guesstimate that there's plenty of energy to do that. But then your adjustment of buoyancy is done continuously through the dive. There's no dynamics where you have to start the dive neutral and then you stay neutral, perfectly neutral for the rest of the dive. That was stage 1, and that worked. You can actually have a tank underwater in a pool standing like magic, as if it was on wings. It works. That worked. But to bring it to the world of what standard scuba is with the adjustments, the idea was go electronics. So then you need a pump. So that took another. We had the first working prototypes in 2019, a month before COVID hit, and it was very rudimentary. Rudimentary doesn't even start to describe it. Zip ties, duct tape.
And you were
batteries.
diving it yourself, as any good developer does.
Of course. Up to today. Yes. Yeah, we were. It was me, Brian, our CTO, Mark, who at the time, Mark had a dive shop. So 3 people were diving it, and everything breaks. Everything. The pumps don't work, and the batteries don't work, and we flood the electronics constantly. Development. That's how we learn about safety. We learned 2 things. Wetsuit compression is a myth, to the extent that people believe that it is.
Okay, we'll have to come back to that.
We'll have to come back to that. And that all of us are instructors. So the people that are developing this are very experienced scuba instructors who taught for years. And the doubt to ourselves was about all the concepts of everything that we thought we knew was just one after the other started to like fall off like dominoes. In the beginning, we dove with a BCD, right? Because the whole point was just reduce weight. And it was good, and it does reduce weight. But then one day we were like, look, but I can get all that flotation. Why do we need that balloon on us? So we took it off, and that was the moment that it was like, all right. We came out, and we said, this is the best diving experience we've ever had, and they're going to kill us. Them, everybody.
Be in the scuba industry.
Yeah. That was because the realization is that that you come out and like that's the best dive I've ever had in terms of a diving experience, and I've seen sand the whole dive. That was it. So yeah, that's now when you asked how long did it take to do this, so there was the COVID years of very hard development because everything is like 3D printed and shipping things companies can't meet. But it wasn't Maui, so we could develop it. In 21, we came out and said, look, we're working on stuff. The experience is great, but we're still developing the certification program. And then the certification program, we went commercial really at the end of 23. So if you want to really like have a time frame of development from when you actually let somebody else who's not family and friends touch this thing, really it was between 2019 and end of 23.
Okay. So give or take 4 years-ish.
Yeah.
Mm-hmm. Right. So now you've been on the market for about 2
years.
And what have you discovered since?
We are very strategic. As you know, a lot of things that we do are strategic. So whatever we're developing right now will be revealed in a year or two. The first year was really to learn how to work with the hubs, the dive shops that are teaching the region. Very good experiences. Those are people that become instructor and instructor trainers and building the fleet. We have learned how to introduce it to all the way from the dive shop owner to the recreational diver, and really answering all the different questions. And they come at the scuba industry from so many different angles. People who want to travel, people that dive next to home, people, the occasional diver, the frequent diver, the industry itself. You know, many of us dive to check each other out. That's what we mainly learn is how to work in our own ecosystem with a world that is still relying on this, weight balloon system. BCD, sorry.
Weight balloon system. No, I get it.
Yeah.
So you have distributed the system through dive centers right now, so people can take the course in dive centers. But recently you have started, is it a licensing type thing that is happening? So how does that work?
So Avelo primarily, from the very beginning, was our head is in training. We're all scuba instructors, and at various levels, from the professional to the teaching professionals, instructor trainers. So the idea was develop the product and continue to develop the product. But this industry is a distributed industry, and people are loyal to brands, and rightfully so. And many brands have their own, I don't want to say niches, but specialties in what they're good at. Let them. As you know, Avelo opens up many verticals because the fact that we improve buoyancy, improve safety, you have the battery itself, the fact that there's a battery on every diver, which is used very rarely by the Avelo diver themselves, but you still need that power in case you need it. So you can do a lot of things with power if you knew that everybody has power. Those are collaborations. They're done under a licensing gear, but they are collaborations. So the Shearwater Jetpack, who is just being introduced today, actually, as a product, it was announced in June. That's a licensing deal, and it's a fantastic relationship that we have with them, and it really does bring their technology prowess to the front. So those are all done under licensing, but what Avelo does primarily is developing all of the training programs.
Understood. The other thing that we need to talk about, because you get that question all the time, so you're going to be able to answer that without any issues. So when we go online and see what all the critics have to say, there's but what about catastrophic failures? What about a rip in the bladder that is in the tank? What about not being able to stop the pump? All those questions have answers. So why don't you tell those who haven't tried it yet?
The answer is go try it, because there is no way to try it without doing the class. And the class, as you know, in the class, you are going to do those. You're going to encounter failures. But logically, let's talk about failures. First of all, we live in an environment of failures, and failures will happen. The difference with Avelo is you get your weighting at the beginning of the dive, as you should. What Avelo does, based on the explanation, right? You have 6 pounds of air in the tank. You're going to consume it. You need to replace as much as you consume. So put the failures in the context of how much water are you actually putting in and out of the tank. The amounts are very small. So when you have failures, they just don't end up, they cannot physically end up in something that's catastrophic or even remotely developing a force on you that will either elevate, that will float you or sink you anywhere near what a BCD does. Let's talk about specific failures, because that's what people ask about. So battery dies. As you know, your dive doesn't actually rely on the electronics at all. It relies on weighting. You actually need to be weighted properly at the beginning of the dive. And you can look at the Avelo system as more of a convenience system. You do the dive. You pump water in to get underwater, but to bring your head from here to here, you need a liter of water. That's about 2 pounds. The rest of it is you pump through the dive. So in your second dive, in your recreational Avelo diver program, you have experienced what happens because your instructor, who was me in that case, literally said, okay, and now we are going to dump all the water out of your tank so you can feel what it's like and you can deal with it. And we're going to swim like that under controlled conditions. But the failure was real, right? We took all the water out of your tank. So, and that's when you get to experience it. Failures of battery not working. The battery doesn't need to work. You dove most of your dive without the battery at all, right? When you needed it just to make an adjustment. That's more of a convenience. But if the battery doesn't work, you just dive. Obviously, you will abort the dive as you should, but it doesn't translate into a change in buoyancy change at all. And I understand how hard it is to conceptualize this, because even when the development team went in, we brought a safety diver with us in case. But it just doesn't work like a BCD. With a BCD, you do need, if the BCD fails, either you have a hole in the BCD or the power inflator gets stuck, the development of force is extreme. And that's what you have in mind. So we understand where the question is coming from. But it doesn't translate. The systems are parallel, and you can't really equate the level of problem. So you have the battery power, you have what happens if water suddenly leaves the tank, and the compromised bladder, again, understanding what the device is will show you that when you have a compromised bladder, the air is still in the tank. It has nowhere to go. Unlike an O-ring failure. An O-ring failure on a regulator, that can be, or a hose burst. Those are real. Like you need to get it out. A compromised bladder still leaves the air in the tank. You can still breathe it and finish your dive. And then you go to the technician to replace it. But it doesn't, you won't know during the dive or care if you had a bladder failure. But I totally understand why it sounds catastrophic.
Right. The other thing I said we were going to come back to is you kind of have this pet peeve about suits and buoyancy in suits. So why don't you tell us about that myth?
I'll walk you through a scenario. So imagine you're part of the development team, and I'm giving you an early Avelo system. And it was a lot of fun. I'm giving you an Avelo system now that you know, because you dove it. And I'm saying, all right, we're going to kick out to be above 100 feet of water so we can do a free dive. You know, it's more like free diving. So we're going to do a free dive to 100 feet and stop. Before Avelo, and I say you have a 5 millimeter wetsuit, immediately your mind will go into, well, but I need to pump water in and then pump it out to compensate for the wetsuit. That's how we all started. We thought that that's what's going to happen. So the first dives were with 3 millimeter wetsuits, and there was simply no change, no noticeable change in buoyancy. And it wasn't quantifiable at the time. Obviously, the team itself would be like, all right, we all taught thousands of students in cold water and all that. Put on yourself a 5 millimeter wetsuit and let's do this again. And there's nothing. Like you go to 100 feet and you just take a breath and you're there without even thinking about it. All right, that starts to be a little suspicious. Maybe that wetsuit. You know, I have 500 dives on that wetsuit. Let's get a wetsuit that has 10 dives on it. And again, it's the same thing. And then you take a 7 millimeter wetsuit. And you go, that doesn't compute anymore. Everything we taught. For 20 years, I taught scuba. I repeated that thing, that you need a BCD because of wetsuit compression. It got to the point that it was ridiculous. We started to put long johns and long sleeve shorty on top, so it will be a 14 millimeter core with extremities that are 7 millimeter, and you still don't have appreciable change in buoyancy to the extent of what you think a BCD would do. And again, this is COVID, so everybody is like in a half shutdown or more. We just started collecting wetsuits from all the dive shops and people and put them in mesh bags and weights and take them down and quantify what is the difference in buoyancy by removing weight until you rebalance them. Hundreds of those. We built complete matrices to see that what is the actual compression of a wetsuit. And now all the data is in the RAD. The RAD is the program online, and you can see that the wetsuit, first of all, we know for sure what the wetsuit buoyancy, what the surface is. The first surprise was that they're not compressing. But even then, that initial data was not accurate because it wasn't worn by a diver. I mean, you can imagine taking a wetsuit, you need to take all the air out of it, otherwise it throws off because then it's a balloon again. And then you go into it with, that still is, the buoyancy change is still not what we feel. So there is the tidal volume, and you can control your buoyancy when an instructor tells a student, I want you to just use your lungs. What they don't say is, I want you to use your tidal volume. I want you to use normal, comfortable breathing, because controlling your buoyancy with your lungs can also be, inflate or deflate. And that is a relatively small force. It's about 500 grams or a pound. And the wetsuit, in some cases, compressed more than that. And we were still surprised how much easy it was to control buoyancy of wetsuit just based on that test underwater. And then we found out that a wetsuit that is not worn by a person is not as compressed as it is. Once you put it on you, it actually loses a certain percentage of its available buoyancy. So we had to take them and put them on PVC pipes to mimic that and then repeat the experiment to see that so much neoprene and so much density actually has a compression and decompression. When COVID ended and we started to talk to the wetsuit manufacturers, we were able to validate that data. They had that. But there's a huge disconnect between As an instructor, you learn that the wetsuit compress, but nobody tells you how much. So you assume that you need a BCD for that. The best line that I got was with one of the wetsuit manufacturers that I won't mention, when they said, if wetsuit were to compress to what you just told me that the scuba industry as a whole believe, do you know how cold you would have been? There would be no thermal insulation. What are you even talking about? How? How is it physically possible that, yes, they do compress, but they compress to a loss of 3 pounds of buoyancy, not 15, which is the perception.
Fair. I would like to talk about some limitations of the system. So obviously, a lot of people that are very active on the internet are people that cave dive and do deep wreck diving and want to, like, and
they want to go beyond.
Yes. So just making sure that I understand that that is not the plan for Avelo. It is a recreational system, or are you planning to have this in the technical world as well?
It's a scuba system, and it will go there.
Well, yes, it will go there, but are you planning it going there, or are people just going to take it there?
Yes.
Okay.
To all of you technical divers, I will say this. The scuba world, as a base, lives on the recreational scuba. Every one of those very, very few people started on a rebreather. The base is still the recreational diving. But suddenly it opens up opportunities that never existed before, because it is a compressor. You are diving with a compressor. And compressor means that you can do all kinds of things with pressure underwater. Just diving with multiple tanks is one option. But now that you dove it, you also know that freezing your buoyancy is not only the world of open circuit. It will go there. We will be part of it. I invented one thing. I don't want to take the inventions from others. And this is a very inventive society of the technical diving. There could be a lot of interest in that community to come in, learn the basics. There is a bit of a feel in the technical diving community that they know everything there is to know about scuba.
Yeah, as a researcher, I've never understood that notion.
Yeah.
We do not.
But suddenly you have a compressor underwater. There are very smart people that could do a lot of things with it. We will be too. And so is our partners. Yes, we will definitely go into technical diving. But nobody will ever capture the entire technical diving, because that's a community of inventive, smart people that can do things. Otherwise, technical diving would have never been involved. I'll leave it at that.
The system itself can collect a bunch of data that we traditionally don't have after scuba dives. What is it that you collect, and what are you trying to use it for?
So what we're trying to collect is biometrics. What we're collecting is biometrics on the diver that shows you how much water is in the tank, how much mass of gas you're consuming, and then when you sum that up, you know what the buoyancy status of the diver is. So in very high level of accuracy, we know not only that you are, net zero on your buoyancy, but how much up or down, how much lift or sink forces are on you. And we quantify that in the, remember how we talked about the tidal volume?
Mm-hmm.
So we show you that when you're breathing normally and calmly, the force on you is within what you can easily control with your lungs. And when you're out, we also show you, if you're a little bit out, sometimes that's comfortable. When you're out, that's how people are consuming more air than they should. Not only the recreational diver, this makes a difference, but even for professionals, it's one of the fun things when you teach professionals who are very experienced, and we're talking then or experience to all the way down the chain. And you show them that, look, you're diving 1.5 pounds negative. You yourself, right? We looked at you and it was like, hey, Frauke, I think you're diving negative. And you go, I don't think so. We're like, no. It shows you that because it shows you what the relationship are. And it is surprising to professionals to see their data. It goes beyond the, oh, this is cool. It goes to the, okay, let's do some cognitive tests and see what your buoyancy, or how do you solve problems if you're out or in that range. So that data opens up the opportunity to, that actually is the data itself, right? As a researcher, don't tell me what I should see in the data, just give me the data, make my own conclusions. So we're collecting all this data. I do think that you'll see versions of this where the resolution of the data is going to be even higher, where you can actually see, right now we're limited by the computer sampling. Once we get higher resolutions, you can do a lot more as any data because you can go more finite on that. And this came from the days of development too, where the Excel sheets from the computers were just showing the peaks every time you pump. But as divers got better and better, the Excel sheet just showed that the pressure always shows you a pattern, that it stays within a certain peak and then a long cruise and a peak. That the realization that it's related to the tidal volume came from, I need to show you that one day, the original Excel sheets that were like, wait, you guys are all solving, you're a small person, you're actually solving for a smaller tidal volume than this larger person. And it came from just, observing patterns. And now, obviously, we have the Avelo Mode that presents it in a much better scale.
Well, thank you, Aviad, for being on the DanCast, and we're looking forward to seeing how Avelo is continuing to develop.
Thank you for having me. It's an honor to be a guest here.